This video is about regressions using Desmos for digital SAT, solving some questions, SAT math questions using regressions. So here's one. A line passes through these points, 11 over m minus 5 over m plus 4/7. Remember, this is the x, comma, y. And then it's another point, x, comma, y. Now you can do this by hand or you can use Desmos. I'm going to use Desmos. I know this is a linear equation. I know it gives 2 points, so I'm going to put those 2 points in a table. A lot of times if it gives you points, put them in a table. So you can hit plus table, you can type table if you want to, and it'll make the table. Some people find one faster, some people find the other faster. And I put my slash first, 11 over m, and then the y coordinate is negative slash 5 over m, and I think it was plus 4/7. That's 1 point. And then this is 8 over m, and the y coordinate is negative 9 over m plus 4/7. Now, I need a slider for m because it doesn't know what to do with m right now. I'm just going to put wm, some letter m, and then I click on m. I could have also, if I wanted to, I could have just said m equals 7, and then it would create a slider for m. Either way, I now have a slider, and notice there are points. Now, just to make sure that I see how they're connected, and I can see where the y-intercept is, which, by the way, is when x is 0, and it touches, in other words, it touches the y-axis, and I'll do linear regression. And so there it is. I just wanted to draw the line. So I'm going to put in the answer choices. So the first one is negative 47 over 3m plus 4/7, and I want to make that a point. So remember, the x-coordinate is 0. That's the y-intercept. And I'll make it a different color. See if I can make it a different color. I'll make it orange. And notice it is not on the line. And then I'll move m around a little bit, or change m, and it's not on the line. So that answer is out. A is out. Now, some people would like to duplicate this. If you click in it, or just hit duplicate, hit the gear icon, then you've got this duplicate. But if you duplicate it, for me, I've got 0, and then I've got to change each individual thing. Well, I guess not too much. Whoops. Maybe duplicating it is the way to go. 59, because they're similar. 3m plus 4/7. So there's that one, and I put that, and oh, look! No matter where I put m, that's on the line. So that one looks good. I'll do the other ones just to show. I'm going to duplicate it again. Duplicate it. I'll duplicate it 2 more times. Done. And then I'm going to put in, what's the next one? 59 over m plus 4/7. Is it negative? Yep. Plus 4/7. I'll make a color for that one. And where's that? Oh my goodness, that one's way out of range. And I'll make this one. Here's the one that's the answer. Again, just so you can see it, I'll put it in red. See how that one's much better? All right, that one's gone. And now I have the last one, which is negative 22 over m. 22 over m plus 4/7. And I'll put that one on there, and I'll make it a different color. You can already see it's not the answer. I'll make it black. And that one's not the answer, no matter where I move m. So I use the regression to find that B is the correct answer. Okay, let me do another one. How am I going to do this? Let me go here. I'm going to do this next one, and I'll drag it onto here, and I will not save. All right, now I've got another one. The equation of a line P is 193x plus ry equals s. Line Q passes through these points. If the system of equations consists of line P and line Q has infinitely many solutions, that means that they're the same line. If you have this in the form of y equals mx plus b, it says of line, they're both going to be the same. One is on top of the other one. There would be no space between them. My drawing doesn't look so good, but they would have to be the same line. So I have to remember one other thing. When I do this regression, if I just press the regression button, it's going to put it in the form of y equals mx plus b. and I may have to do some manipulations because this isn't y equals mx plus b. To get this in y equals mx plus b, I'd have to subtract 193x and divide by y. So I'd get negative 193x plus s over r equals y. So now that would be y equals mx plus b. So I might have to keep that in mind. I'm going to go to Desmos. Let me, how do I delete? Wait a minute. I want to delete the whole thing. How do I delete the whole thing? I didn't want to do that. I want to delete the whole thing. There it is, delete all. So now I'm going to put this, and I'm going to use regression this time. And when I use regression, I'm going to do one. Oh, wait, before I do that, I have some values, I think. Yes, I'm going to make a table. I'm just going to type table, and I have 0, 4, and 5, 2. 0, 4, 5, 2. I got a beautiful table. And here's what I mean. If I add regression, I've got to be y equals mx plus b. So I got to be careful about that. I'm going to put it in that same format in just a moment. Let's see. I want to put 193x1. If I type 1, it'll just give me that. Plus ry1. If I just type the 1, it makes it a subscript. And then instead of equal, I put tilde s. And now I've got my values for s and r. And I will do this, s plus r, and it's 2412.5. Now I cannot enter that in Blue Book for SAT. I can only get 5 characters, including the decimal. So notice that's 6. 1, 2, 3, 4, 5, 6. So I'd have to enter 2412 or 2413. I could either truncate it or round it. Either answer would be acceptable. Now what if I did it the other way? What if I pressed this button? I got y equals minus 0.4x plus 4. Now what? Well, I'd have to put this into that other format. Y sub 1 equals negative 193. Whoops. Negative 193 x sub 1. Whoops. Sub 1 divided by r. And then plus s divided by r, and I get the same values that I got before. So I have to know what to do with a little bit of this, but I can use Desmos to get the answer very quickly. I've got another one here. This one I think is not linear. I don't want to drop it there. Don't save. This is a quadratic function. Let me get rid of this one. Gone. Now I have to know something here. This is the vertex, 6, negative 10. It's the low point. It's either there or there. And I'll tell you the secret thing I have to know in a moment. All right, it's got 2 points. I'm going to make a table. I can press plus table and make a table that way. And I get 6, negative 10, and 0, negative 1. Now, watch what happens. If I here put in quadratic regression, 6, negative 10 isn't the vertex. What have I done wrong? Well, the problem is that it's only got 2 points, and it can make a lot of different parabolas with 2 points. So I have to do one of 2 things. Either put in a third point using 6, negative 10 as the vertex, and if 6, negative 10 is the vertex, this thing is symmetrical about it. It should be a negative 10. Negative 10. Oh my goodness. Negative 10. I botched it. So I have this point 0, negative 1. That's 6 to the left of it, so I've got to go 6 to the right of it. It's also going to be at negative 1, so 12, negative 1. So if I put that point in, 12, negative 1, now I've got the proper parabola, vertex, and what does it want? It wants g of x equals 3. So I'm going to make the equation here. That's f of x. And then I'm going to put g of x. I could also, I'll show you another way I can do it. 3 times f of x plus 4. And now I can put g of 2 minus f of 2, negative 24. Now I could have also, instead of done that, I could have just done the function g of x is 3 times f of x, which is 2 plus 4, minus f of 2, and it comes out to the same number. Now, I could have also, if I didn't put in that third point, let's say I didn't think of putting in that third point, I could have used the vertex form of the equation. Let me get rid of the regression. And the vertex form is y equals a times x minus h squared plus k, where hk is the vertex. In this case, that's 6, negative 10. So let me put that one in. I'm going to make that the regression. I'm going to put y sub 1 tilde a times x minus h squared plus k, but I want to put in the values for h and k, so it's x minus 6 plus negative 10, which is just going to be minus 10. And I should have put a sub on the x. And see, now it's got the right vertex with 6, negative 10. And then I would proceed exactly the same way. I would put f of x equals, I've got a as 0.25, equals 0.25 x minus 6 squared minus 10. And then I could put g of x equals, and it says 3 times f of x plus 4, and then I just do g of 2 minus f of 2, and I get negative 24. So either way with that one comes out right. All right, let me get rid of this one. I have another one to do. Let me find it. Don't save it. Exponential function. This is an exponential function given above. Well, it's actually given below here. Passes through the points C, 9.2, and 2C. Well, again, I will make my table. I can type it or hit plus table. And I've got, what is it again? C, 9.2. C, 9.2. I'm going to have to make a slider for C. And 2C, 31.04. I put 2x. That was not good. 2C. And I'll make a slider for C. DC, make a slider for C. I've got a beautiful slider for C. And now watch this. If I do exponential regression, notice I have something times something raised to the x. This isn't something times something raised to the x. This is a to the x minus b. So I don't want to use that regression. I want to use the format that I'm given here. So I'm going to put y, and again, I hit the 1, and it makes it a subscript, and then tilde, shift, apostrophe, a raised to the x1, and it makes it subscript minus b. And now I've got, it says, the question asks, what is the value of b? Well, notice this, no matter what I make c, b is negative 4. If c is 0, the equation, oh wait, that's 0.1. Hold on. Why can't I get it to 0? If c is 0, I don't know what that is. That's not an exponential equation. But any other value of c, it's an exponential equation, and it tells me b is negative 4. So what is the value of b? Negative 4. Do I have another one? This one might be faster just to do by hand. I'll show you how to do it by hand, and then I'll show it on Desmos. I'm adding fractions here. So notice under here, I can factor out xy, and that leaves in parentheses, x is what's left there, minus 4. And so see, the common denominator is xy times x minus 4. This one has the whole thing, so I'm just going to distribute xy minus 4y. This one doesn't. It only has the x minus 4 part, so I have to multiply by xy, and that's going to be x. I'm just going to distribute right away. Xy squared plus 7xy. And then if I add all those together, I get xy squared plus 8xy minus 4y divided by x squared y. I'm distributing minus 4xy. And which one is that? That's D. But okay, so that's not so bad. But what if I don't think to do that, or if I don't want to do that, can I do this in Desmos? Absolutely. All I have to do is put in the top equation or expression. I'll turn it into an equation. Let me get rid of this, delete all. So I'm going to put my parenthesis, y plus 7, and notice it says x is not equal to 4. Well, that would make this denominator 0. And you can't have 0 as a denominator. Plus y times x minus 4 divided by x squared y minus 4xy. And then notice it's got an error here. What does it say? Try adding an equal sign. Okay, equals. Okay, I'm just going to put equals y. If I put equals y or equals 0, it gives me something, and then I can compare it to the other equations. So now I'm going to put this one. This is a, x, y minus 7x minus 4 divided by x squared minus 4x, and then I want to put equal y. And note, xy plus 7x minus 4 over x squared minus 4x. I guess that's good, but notice they are not the same equation, so that one's out. Here is b. I'm going to put that xy squared plus 6xy plus 4y divided by x squared y minus 4xy, and I'm going to make that one equal 0. I want it equal y. And notice that's not the same either. Do I have that first one right? Y plus 7 over x minus 4 plus y times x minus 4, x squared y minus 4xy. I worked this thing before, and I think D is the right answer. Yeah, okay. I thought B was the right answer for some reason, and it wasn't what I expected. xy, C, plus 8x plus 4, is that it? Divided by x squared minus 4x, and then equals y. And notice that's not the same equation. And now I'll do the last one, xy squared, I forgot to put my slash, plus 8xy minus 4y divided by x squared y minus 4xy, and then I want to get rid of all that, equals y. I don't know how I had it there in the first place. So notice that is the same equation. It shows it's exactly on top. What was throwing me off is this one. I could have sworn the first one was very close to it. Let me see. Y plus xy plus 7x minus 4 over x squared minus 4x. Yeah, I don't know. I could have sworn I remember that it came out very close to it. Now, yeah, it was almost like on top of it. But now it's not. And I'm trying to see if I typed something wrong, because it should be, when I worked this before, xy plus 7. Oh, I put minus. It's plus. There you go. Yeah, see, that's what I was expecting. See how close it is? But you can see it's not exactly the same. This one is exactly the same. See, I typed something wrong. And hey, I could type something wrong and then get the wrong answer. But anyway, that's how to use Desmos to find something like that. So regressions or comparing expressions can be done on Desmos pretty easily.